Wow, this is amazing. I didn't expect this many. I'm super excited to have you all here. Thank you for coming. We're here to talk about real-world Hadoop use cases. So if you expected something else, you might want to check your calendar and find the right room to go to. I'm Eva Andreasson. I work for Cloudera, one of the top-rated startups in Silicon Valley right now. Some might claim that is because it's such a great company to work for. But more seriously, we are the company that provides the market-leading distribution of Hadoop and its ecosystem projects. And I'm here today to present, together with Lars Sjödin from King.com, one of the most prominent online gaming companies, some real-world use cases. How do you use Hadoop for big data processing? And you're going to see Lars again. He will sit there while I'm presenting, but he's going to come up on stage again soon. So before we begin, how many of you actually know what big data is, like feeling familiar with the concept? That's a big increase since last year. That's awesome. I was here for the first time at JFocus last year, and I was very excited. It was a great conference. Thank you, Matthias, if you can hear me. And it's great to be back. It means that this topic has caught some interest. And how many of you have actually played around with Hadoop? I'm happy to see some hands up this year. That's great. And how many of you use Hadoop in production? I'm expecting you to raise your hand. That's fantastic. Anywho, for you who don't know, big data is an industry term, a widely used industry term that foremost refers to three things. The increased volumes of data generated in our environment today, the increased speed of which this data is being generated, and the increase of data types, the variety. There are new data types you want to capture and process. And all these characteristics of big data put some stress on traditional systems. It comes with some challenges. For instance, how do you actually process all this data if you have the same fixed time window or make it readily available? Or how do you actually keep up to speed with all the data coming in a more rapid pace to make sure you can do all the ETL and cleansing and decoration that you need to do? And also, traditional data storage and processing systems comes with the challenge of quite inflexible data models. Once you've determined a model to apply to your data, it's very costly to change it later if you happen to want to ask a new question. And also today, it's more and more common that you want to ask new questions, maybe across different kinds of data in your organization, to improve your services, to improve your offerings, make them more competitive, compelling, more personalized, more customized, reaching your customer in a better way. And since data is limited in its current storage and not easy to access across these silos, there are some problems out there in our infrastructure today that actually caused this technology called Hadoop to rise to the challenge. So what is Hadoop? Well, Hadoop is two things, and a lot of other projects around it, but mainly two things. It's storage. You have a data file. It gets split up into equally sized chunks, spread across commodity hardware clusters, meaning it's also replicated across them, meaning it's very robust. Even if it's commodity hardware, if one node goes down, you have two other copies or three other copies of that piece of data. And it's also very scalable. If you get more data in, you just add machines. Hadoop is also processing of data. And it basically turns the whole approach of bringing data into your processing system around and bringing the processing to your data where it's stored across all these commodity servers. So MapReduce is a Java-based, parallel, very scalable framework that you can implement MapReduce jobs in. And then as you launch them, they get spread out across all these chunks of data and does the processing to those little pieces in parallel, and then aggregates the results back, sorts it for you, and kaboom, you can ask a terabyte or 10 terabytes or a petabyte in a linearly scalable fashion. Okay, enough of the recap. I hope you have a concept of what Hadoop is by now. Let's talk reality. Okay, so social media is tremendously popular. I mean, how many of you use Facebook? How many of you use Twitter? Okay, so I don't have to explain what Twitter is. That's good. I use Twitter a lot. But social media isn't only for users. Social media is very popular in businesses today. Why? Well, take, for example, the marketing teams. What if you can tap into that social graph that targets your audience? Like, what if you can find the most influential person who tweets messages and get retweeted the most? That is important for your industry. What if you can tap in your message into that person's tweet flow? That's very powerful. So businesses are looking for ways to incorporate their marketing strategies with social media. So I'm going to use that as a high-level example on how to use Hadoop. Because Twitter data, think of all the Twitter data. It's kind of big to download into your traditional RDBMS and do processing on, right? How do you fit that? So my big question, this is my only marketing spiel, you know. This is our new marketing campaign, Cloudera, Ask Bigger Questions. So the big question we want to solve is, of course, how do we find the tweeter which gets the most retweets that is most important for our industry based on some industry terms. That's our use case. So a query language that allows very easily for similar questions like that is, of course, the well-known SQL. It allows you to filter on terms. It allows you to aggregate by a certain key. It allows you to count. And it also provides sorting capabilities, right? But again, the backend, the most common backend of SQL is limited today. The RDBMS systems kind of can't handle certain aspects of this use case. For one, the output of the Twitter API happens to be JSON objects, is one version of it. And JSON objects is a nested data type. Nested data types, loosely structured data types, doesn't fit very well into traditional models, traditional schemas. And tweets also happen to have very variable schemas. So it would require a lot of ETL and cleansing and processing per tweet to actually get it into a traditional model. And then, of course, I mentioned the size of the set. Depending on how much data you want to analyze, it might be other constraints like cost or maintenance or whatever. These challenges is actually well-known facts that Hadoop takes care of. So let's explore Hadoop to solve for simple querying on lots of data with nested data types. Have any one of you heard about Flume? Great. More than two. So Flume is an ecosystem project of Hadoop. Flume is a data flow, agent-based kind of data ingest system. It follows a traditional pub-sub architecture. And the endpoints of this data flow are called sources and sinks. Sources can be configured to push or pull events from, let's say, appending files or other kind of event streams, producing events, like the Twitter API, the Twitter fire hose. You know, there's a pipeline of events that you can listen to, and sources would be the entity in Flume listening to those events or polling for those events. Sinks, on the other hand, are the ones writing the event further in the pipeline. So they can write to other Flume agents or stable storage, such as the Hadoop distributed file system, HDFS, that I mentioned. And sources and sinks communicate through channels that you can implement based on your requirements, like performance or reliability and such. And it's also event-based, so there are some metadata around each event that you could choose to extract for filtering, for instance, or routing, or other use cases that you'd like to apply to the event as it comes in through the pipeline. And Flume comes with a lot of sources out of the box, syslog, netcat, others. But in my example, I wanted to highlight that you can easily extend to any new data type or stream that you'd like. The flexibility of Hadoop is a key message I want to get through. So Twitter API, you can kind of listen to events using the Twitter4j library. It's a Java client. And we need to create a custom Flume source to consume this stream. The source will then process data as discrete events and filter on the keywords that are essential to our industry. So by doing so, you can filter out the Twitterers that actually are active in some community important to retail or medical or healthcare or what have you. And then our custom source will publish the event on the channel that will enable the sink to write to HDFS directly. And lucky for us, an HDFS sink comes out of the box with Flume. And the neat thing here is if you extract, as the event comes in, the timestamp of that event. Remember, an event through Flume has some metadata that you can extract. What if you extract the timestamp and configure the sink to write in a partitioned way based on year, month, date, and hour into HDFS? Then you can already, at data ingest, partition your data for better processing options later. But you can choose to partition in some other way if you want. But it's an easy way to bucket up your data within HDFS if you'd like to. Okay, so I will show some code. There's more code online, and I'm happy to point you to that one after this talk. But I'm going to highlight some things here to convey the message. So this is the Flume source interface that we would need to implement, and it contains more than this, but you can basically look here and see there's a configure method you can implement if you want to assign some security credentials or what have you. And then there's a stop method that you can implement if you want some particular things to happen when you want to close the source. And then the most important part is the highlighted one here, the start method. And that is the one that starts the thread that will connect with Twitter, the Twitter firehose, and through the Twitter API and start listening to the events as they come in. It's also the one that processes the events. So you can do things with that event in this method, and then it will post it on the channel for the sync to publish. So this is the key method you need to implement if you're doing your custom source. Going further into this start method, here's a chunk of code that you can use to implement a Twitter source. This is basically using the Twitter4j library, the API, and what you can do there is to create a listener, a status listener object. And it actually provides a callback mechanism for catching new tweets, very neatly so. And in the onStatus method here, also highlighted, is the method that is called for every new tweet coming in. So we want to drill down further in the onStatus method to actually do what we want to do with event. So we need to implement that too. And then the code at the bottom is just to showcase that you can set, authorization and other things of interest that you extract from the config. Okay, so what do you want to do in the onStatus method? Well, let me take a little moment and then explain what JSON data is. Do you know what JSON format is? Maybe it's a stupid question, I don't know. Wait, I don't have to explain it. JSON is a format. It's nested. It's very neat. It's very easy to use, and it's gained a lot of popularity. But as mentioned earlier, it doesn't fit out of the box into traditional data models and schemas. So here, what I want to highlight is that in the onStatus method, you can actually extract some metadata and then write the JSON object as is. No ETL, no processing, no nothing. We only extract the timestamp because we wanted to do that partition. But you don't have to, right? You can actually write the raw format into HDFS. Why? And what's the benefit? Well, you can do the ETL and the processing and schema application at read time. That's a big key with Hadoop. The whole concept of Hadoop is do not throw away any data when you store it, because you don't know what you're going to ask for later. You might want to ask something else, and if you've cleansed your data at ingest, that value might have gone away. So it's the raw data format written into HDFS, and we're going to do the schema application at read time. Okay, how do we do that? Well, lucky for us, Hive is another ecosystem project of Hadoop. It's actually the data warehouse of Hadoop. Not really. It's implementing an SQL interface called HiveQL. It's a subset of the standard SQL interface. And it actually interprets your SQL query and translates it automatically out of the box into MapReduce jobs. So you don't have to do that. You can, but you don't have to. And it returns the results of those MapReduce jobs to the client. And if you paid attention, the schema is applied on read. So MapReduce extract the schema during the mapping phase from the data, the way it's stored. Hive, on the other hand, uses a separate library called the SERDE, serialization, deserialization. And there are a lot of SERDEs coming with Hive out of the box. Hive also supports the traditional scalar types like integer, float, string, but it also extends the SQL interface and supports more nested types. Haha. It might actually work with our JSON object. Great. So, for instance, structs, maps, arrays. Hive also has a metastore that is stored in a traditional database where the table definitions are stored. So it's separate from the data, meaning the Hive queries are fully agnostic from how the data is actually stored and when and such. Provides some flexibility. So JSON surveys are not out of the box with Hive for our example. Again, to highlight that it's easy to add data formats. All you need to do is implement the survey interface for a JSON object, and it will apply to any data stored as JSON from there on. So not only for this use case, but if you plan to store other JSON objects down the road, you can use the same survey. It's very easy to extend Hive to support new formats. Again, flexibility in the data model, flexibility in the schema. Very, very good values when it comes to big data, right? So, I'm almost wrapping up my session. I hope you got a hint and inspiration for how to experiment with Hadoop for big data use cases. Putting it all together, we had the Twitter feed, constant stream of tweets, nested structures. We used Flume to take care of that feed. We implemented a custom Flume source to interact with this new streaming data type. And we saved it in its raw format, JSON objects, into HDFS in a partition per timestamp fashion. Hive then allowed us to query this data. And again, we implemented our JSON survey to be able to read that data type. And I can use my favorite SQL tool to connect with Hive through ODBC or JDBC, right? Ta-da. Simple. Here's the query. Big question I asked in the beginning. And as you see, just as a highlight, the screen name is extracted from the user field, which is in its own a field from the status field, entry, right? So this is a nested format in the query, showcasing what I just explained. So now I can know who's the most influential Twitterer for the gaming industry, maybe. Okay, highlight. If you want to do faster queries, we as in Cloudera, has launched a new product that is like 3 to 40 times faster than Hive, depending on your query. Google Impala and ask me questions later. And if you want to learn more, we have a demo VM that you can download and play around with. And CDH-user is a very good forum to ask random questions about Hadoop. All our committers and contributors and engineers are on that, so you can get direct help and info. We also have a very rich blog where you will find the code in more detail as well if you go and search for the Twitter use case on our blog. No further ado, Lars, are you ready to talk about an even more real use case?
Yeah, this is going to be very real.
Wonderful.
Oh, you prepared it, thanks. Would you switch to the... Yeah. This presentation was prepared by my spiritual leader. My name is Lars Sjödin. His name is Mats Olof. And we were the ones who introduced this way of thinking at king.com. What I'm going to present is how you can make Hadoop the central part of your entire data structure, actually, within a company, and what sort of comes with it if you do that. So, back in the days, when I started a long time ago, 3 years ago, the company had a site, the world's biggest gaming site for money when it comes to casual games, not gambling games, but skill games. That was quite nice, and it was a nice site with a sort of developed in Stockholm. Everything was in a regular sharded MySQL databases, normal sized data, and everything was fine. We could run the business intelligence queries against MySQL data that was also running the live data, and there was no problems. It was very comfortable. But then in 2010, we tried to do something on Facebook and Google+. And it turns out that it was extremely popular. And also the business on Facebook, for those who don't know it, is usually 10 to 100 times bigger than any other site. And it doesn't necessarily generate the 100 times revenue, but there are a lot of people on Facebook that will access your site. So things went well. We expanded. The first two things are not so interested from a technical perspective, other than we needed to get things under control from a sort of organizational point of view to make sure that people don't just implement their own solutions and we won't have any sort of shared view of the data set. On the third point there, we do tracking through log files instead of RDMS. That's what I'm going to talk about. That's sort of the entire rest of the presentation. That's one line here. And the reason we did it is because we were overwhelmed by the volume increase. The amount of data that poured in was unbelievable at first, but today I would say it's beyond what I could ever have imagined 1.5 years ago. Also, the variety of the data and the types of data that we actually collect and look at today is also beyond what I could ever imagine. We have 15, 20 people only analyzing data from various points of view, and I don't mean financial points of view. So we have a lot of different types of data, and it all goes through the same Hadoop system. So in the beginning, we had data. We had more data, and it sort of added up fairly okay with the increase of number of players that we had on the games. This is when we had one or a few games up and running. Then we added more games. We added games on mobile. We added more games on Facebook. So we had the amount of data, and then we added some more time. Some more games came in. And this is not an additive chart, but it would add up. So with all this disperse or disparate data coming in from many, many games resulted in an increase in the amount of data that we could process. So this is actual data that I haven't seen until yesterday. Somewhere around 2012 early, I made a prognosis for how much data there will be. How much storage do we need to actually store all this data? Because we store all data. We never throw anything away, like Facebook or Google, for example. We don't throw data away because we know we want to look at it, not just from a financial point of view or from legal perspective, but we want to look at it to understand our business better. So I made a prognosis, and it sort of already then was increasing exponentially, both because of increased customer, but also because we learned how to work with the data more. So we added more and more data to analyze in this set. And it's still increasing exponentially. So now we gather around, I think, 3 billion events per day. And if you ask next month, it's going to be even more. So what I want to pause and sort of describe now is the events that I'm talking about is obviously not transactions, because we don't have, unfortunately, 3 billion transactions per day. That would be awesome. But it's also all kinds of data, sort of a person starting to play a game, a person finishing a game, how well they did in the game, if they saw a certain type of interface within the game and they chose to click a certain button, things that we're curious about. It's also some tracking for financial purposes, obviously, but I would say that's 1% of all the data. Most of it is about knowing the customer better, because we deliver software as a service to the customer. They play our games because they're fun. We need to understand what's fun for them, so we can make them good for them. So Yeah, there will be some quotes in here. This is one of my favorites, actually. So, Ronald Reagan, this eternal source of information and clarity. So what this is about is actually, I was happy to see the T-shirt today with Ask Bigger Questions. That's actually what it is about. I didn't know it, but fits very well. So what Reagan just didn't understand is obviously that the more information you get, the more questions you're going to have. So that's what happens when you get bigger and bigger data, and that's why your data gets bigger and bigger as well, because you get more and more curious. So, well, let's see if Reagan could get this. Right. This is now going to be a deep dive where I'm going to anchor Hadoop within the system. It's going to look a bit messy, but I'm going to talk you through it, so don't worry. So first, some abbreviations, and that's our internal names for our games. This means Candy Crush Saga, and you can actually meet the team if you want to. They're sitting here somewhere down in the lobby, coding, actually, for these 2 days. One of our more popular games. We have Pet Rescue Saga. They're not here. They're sitting in Malmö. We have our mobile games, the same games, Candy Crush Saga for mobile, and we have Bubble Witch for mobile. These games, yeah, that's mobile. That's a handset. These games all are connected to regular Java servers. They have their own infrastructure in terms of sharded user databases, no SQL storage for all the user data, nothing special, just a regular client-server implementation, which scales really well. But those systems only serve the real-time purpose of having the customer playing the game. It does nothing for the business intelligence, it does nothing for finance, nothing for analysis of the games, it's just serving the end customer and nothing else. So the thing that we do here, that's the servers, yeah. We write log files, and log file is maybe not a good name because you think of error log files or warning log files, but that's not what it's about. It's about data that we want to process, and these are actually really structured. It's one line per event. There's a timestamp and an event type, and using that event type we can decode the rest of the event. That will enable us to know what all the other fields in the event mean and what type they are. And all these are then transported to a common storage today. So I'm describing our architecture as it looks today, not how we want it to look. I'm going to talk about that in the future, in the upcoming slides. So we all collect them. Every hour we collect them. Yeah, the log server. Now we have the log files up there. They're waiting to go somewhere, and they go into the Hadoop system. So with a couple of hours delay, we have the data in Hadoop, where we can do all kinds of things with it. So one of the first things that we realized is that we would like to be able to query this data somehow. And Hive is an obvious solution, because if you've experimented with writing your own MapReduce jobs, or maybe even Pig, you know that it's going to be complicated. So Hive is a really good addition. We have our metadata for the events. The metadata was present when the events was written to the file, forcing the data to have a certain format in the log files, and now it's going to be present when we decode the data and partition it into Hadoop, and also going to be very present for Hive to interpret the data when we read it. So the metadata is a crucial component. We don't just throw unstructured data into Hadoop with no secret decoder ring, because that would just be a waste. So onto that we add a regular system that I guess a lot of people use because it's a Swedish company. I'm not going to make sort of free ads for them, but it's what most people use. We also store some data in MySQL, where we do some aggregation of data. We make sort of slowly changing dimensions that we extract there so we can use them from QlikView again, which is our presentation tool. And we keep a lot of dimensions as well. We extract data in various formats, depending on what kind of reports we want to make in the end. But Hadoop is the foundation, the sort of source of data where everything comes from. Yeah, and then we have some people. This is actually the guy with the hat, I think, is a developer, and the other people are business managers of some sort. They want to know stuff, so they're obviously gonna, they're the business, the ones we're serving. So they get their data from QlikView. Nothing weird about that. They can cut and slice and filter the data that we have presented for them in QlikView. But we also have another source of information. Yeah, they want to have their key performance indicators. Some people work in Hive, which is a nicer way to access Hive, to write your queries and look at the jobs and data. And this is used by our nice educated statistical people, the doctors. They actually are sort of mathematical doctors for some reason. So yeah, he looks at the data, or she, and sees a pattern. Yeah, I see patterns. This is usually done ad hoc. So these people tend to run extremely heavy queries that collate data, data that is not necessarily structured in a normal way. It could be graph connected if you have a social graph, which we store also indirectly in the Hadoop system, or it could be aggregating data which is from 1 month old, sort of what did people who installed 60 days ago do today, or the effect of a release. A lot of one-off analysis things that they can do with the data. And sometimes they even go back and see what happened a year ago. Stuff that is not normally in the regular reports. Yeah, this guy is really hardcore, works directly on the command line interface. And they feed it all back in various formats, comma-separated lists, or just a yes or no, back to the business. And we make money from that, actually. So that's how it works. But the key thing with this picture is that everything comes in through Hadoop. There is no way for us to present a number or a KPI or any other value for the business without extracting it from Hadoop, because all our data is there. I think that's the kind of twist you need to make for Hadoop to really matter, because what you will struggle with if you try to combine data sources with maybe your normal RDBMS system is that you're not going to be querying the same data set, exactly the same data set. So by just dropping the old way of doing things, the RDBMS, we can actually get consistent reports and data that fits very well together by just using the Hadoop as our data source. This slide was supposed to be in there somewhere in the middle. It just shows that even though we're using Hadoop, and when you work with it as a developer and when you try to pitch it to somebody, it's going to look very technical, but you have to remember you have to put something graphical on it, because whoever is going to use it is going to want some kind of GUI. And you can just use whatever tools you have. This happens to be QlikView. The cats are there to hide the actual numbers because they're apparently secret. But they're very, very low, I hope, for this number. So we keep all the dimensions, or a lot of interesting dimensions, when we extract data from Hadoop. The cool thing about having all the data in the Hadoop system is that we can actually, if we find out, oh, but we want another dimension, we can just rerun all the data, because we have all the source data in an unaltered format. Let's see how I'm doing. Yeah. So, why do we use Hadoop then? Yeah, that could be a reason, as good as any. We are, actually. Now, we tried various systems. We used the reporting tool itself has some basic data warehouse capabilities. We used that to begin with. It didn't hold water. After a few months into the Facebook Zing, we couldn't handle the data. And just in time, we added a MySQL with a special database engine to it, I think Infobright, and that worked well. And just when the data was sort of becoming too much for that to handle as well, we had a Hadoop solution in place, so we can just shift it out. So we sort of saved by the bell maybe a week before we couldn't actually process the data. But the key thing is Hadoop scales, and you can easily add servers, and we do that actually. I'm ashamed to say it, but we add servers maybe every month, actually. And just throw another server in, go to Cloudera Manager, add it, and it's up and running, and nobody noticed that we've done anything. It just works, and that's really awesome, actually. So when we add more people doing queries, add more servers, and it runs faster. The servers that we add are really cheap, so it's cost efficient in terms of comparing to buying a big brand computer. I can't think of some brands that I used before. Our servers cost maybe 1,500 euros a piece, and they're regular machines. And it's also easy to integrate with the various statistical packages, so whatever you use. We use occasionally R, or we've experimented with Mahout. I don't know if you heard about them. Yeah. So I'm just going to... Oh, yeah, I forgot the most important thing. I'm going to go a bit faster so we make some questions. Yeah, we add various stuff to it. Python, we use awk, we add whatever we need for the job to it. But also it's fun, actually. I think that's the key thing. When you work with a traditional system, with the big iron company and maybe the company providing Java, it's not always that much fun. And you can't make it that much fun either, because there are specific solutions you need to use. But in this case, it's quite new, it's free for all, and whatever you know can actually be applied in this system. So that makes it extremely fast, and developers pitch in whatever is needed to make it work. So, why wouldn't I recommend it? That's another important thing. You need people who are motivated and find it interesting. If you can't find those people, if you're not a company that attracts that type of employees, stay away from it. Do you think you have big data? Verify that you do, or that you're prepared to have it, and then go all in. It's not a sort of, I would like to try it, maybe we can have it on the side kind of solution. You really have to make sure you need it, because it's going to cause you a headache if you don't. Yeah, and it's pretty immature. I would say that's changed now, but it's not plug and play, so you can't just take components, download them, and think you're going to have something up and running. We actually, that's the reason why I'm here, because we use Cloudera, because you get a package that actually works together. I challenge you to put together your own package that works together with Hive and Hadoop and Hue and everything we want. You might succeed, but you're not going to be able to upgrade it and have it working all the time. So I would say, if you're not a wizard, just stick to one of the distributions, and you're going to have more fun doing your work instead. Cool. Yeah, just briefly, this is what we use. Cloud. Obviously a lot of Java. All the other things we use actively and have in production, except a few. But yeah, we are a bit free-spirited when it comes to technology. So, metadata. I never discuss discussions. Thank you. The metadata dog. This is what's needed. I talked to a former colleague earlier, and he said that they had some interesting questions regarding how to decode data in Hadoop. I think the question was answered actually previously, but the key thing is making sure you have your metadata under control. So you have data stored, how do you describe it? And this is going to be a very complicated picture, but all it's going to say is you have metadata, we have our game, we have a developer with a great idea. He first wonders, how am I going to describe this data? Creates the metadata for it, implements it, then implements it in the game, the Bubble Witch Saga game, which then starts to log this event. That's the order of how you do things. You don't just log an event and then try to describe it. The metadata dog makes sure everything is okay. It goes into Hadoop. So you have the data scientists, by using the metadata, can actually pose a query to Hive and get a result back. And this will generate money for the business. This is one of the key things. It's not a storage for ad hoc data. It can be, but if you create the description of the data first, you're going to have it much easier. So that's all about governance. Yeah. So for the future, just going to skip through. I think this quote was this Chinese emperor when he was asked about the French Revolution, and this was quite recently he was asked. So what impact do you think the French Revolution had on the Western world? And he said, it's too early to say. I think that's very clever. So just a quick recap. This is how it worked. We write log files, they go to a log server, they're transported to Hadoop by rsync processes. Not a very high-tech solution. It works, it was very robust. How we want to do it, and trying to do it, is to broadcast data using Flume, for example, or Kafka, we haven't decided. Probably both for various types of systems. And we will have a listener in HDFS to write down the data. We're going to have other different cool systems listening to the same data. I think these are transmitters and these are antennas. We don't run wireless in the server room. Cool. I think we should open up for questions.
Well, first of all, thank you. That was really, really good. And also thank you again, everybody, for coming. It's amazing to have this kind of audience. I see a first question over there.
Yeah, this is for Lars and Kit. When you create your material as used into Kit view or whatever, and then someone says, please give me this report but with some twist on it. Then when you rerun it, you will probably not rerun it on the exact same data because we have more data than it had the other for the production we did the previous time. So do you don't care about the traceability, or have you solved that in some way?
Yeah, so the question was when we add more dimensions, I guess, to the data, and we rerun the query to from Hadoop to our business intelligence system, ClickView. Do we then risk of getting a different data set or a different data? And no, because all the queries that we run are actually aggregated per day or hour in such a way that they will not change if we rerun them. Yeah, so we never make reports or data sets that means that you would insert data in the past. So nothing can have happened in the past. If you get a booking and it's marked as being a month ago, you're going to have to deal with it being a booking today or whenever you want to book it. That's how we deal with that, because we don't allow data to change in the past.
Yep.
Can you tell us about what's the size of your cluster right now and how many users are actively using Hadoop?
Yeah, so the question was about the size of our cluster and how many users are actually using the cluster. It's quite small by Hadoop measures. I think we have 20 or so machines now, and roughly 20, 25 people actively using it.
How much data are you storing right now?
Yeah, I was trying to calculate how much it would be. I think we have a capacity of few hundred terabytes in total in the system, which I think is going to be enough until August, September. So, but as we add machines, we also add capacity, and so I calculate that we continue to increase roughly exponentially for a while now. So it's going to be some terabytes, and the next number, I don't know what it is after it.
About Hadoop, what Hadoop versions have you used in the past? Because it's a little bit confusing about what version to use and how big is an upgrade, how much effort do you need?
Yeah, then since we stuck with the Cloudera program, actually things got much easier with the upgrades, I have to say. Because the problem we had in the past is not so much compatibility with the stuff that we've written. They're fairly compatible. But compatibility between, for example, Hadoop and Hive, that could mismatch. And then we sort of might need to force upgrade one when we upgrade the other. And I think the upgrade path, if you choose one of the distributions, is going to make life easier for you.
So Cloudera's distribution of Hadoop is actually based fully in the Apache community open source projects. We pull them down, we test them out together, we fix issues, post them back, and then package it up in an easily deployable RPM kind of download install. And that's open source and it's free. So.
But how can I imagine the upgrade? It's also only installed software or also upgrading data?
No, data doesn't need to be upgraded. Data is always stored the way it is. We never change how we store data.
And with risk of getting into commercial stuff, but Cloudera Manager helps very well with upgrades. So if you want to upgrade your cluster, Cloudera Manager is a helpful tool to do that. There was a question up there.
Question from the telecom world. Have you got any customers who are actually extracting from ASN1 instead of JSON?
We have plenty of customers. Some of them are telecom. I don't know the detail of that format, but we can follow up afterwards, and I can connect you with some people who can help out. Yep.
You mentioned that you don't use this for transactions. Obviously, you need financial transactions. Do you know any users of Hadoop that do that? And how they solve the transaction integrity?
So Hadoop has been for a while a batch-oriented processing platform. It's moving towards a more real-time with tools like Impala, but for pure transaction processing, you know, an RDBMS still has some quite nice optimizations for those kind of workloads. There are customers who are implementing it, but it depends on your SLA and you know, certain latency requirements.
But
yeah.
I would say that the clever thing that we do the transactions in a regular RDBMS, but we also track it when it happens. So we track receipts, we track validations of receipts, we track everything that we do during the processing of a transaction. So when we calculate bookings or we want to extract revenue from bookings or prepare the books in any way, we do it using the Hadoop data, never the RDBMS data. It's just used to make the real-time transaction. We might reconciliate later, but that's again going to be done with the Hadoop data against a payment service provider or whoever we reconciliate with.
Any last question? Yes.
How big was the challenge for you to introduce and start using
How big of a challenge it was? Actually, it was not that big of a challenge for us because we desperately needed it. So it made it a lot easier. We had so much data we couldn't use. We used the fastest time linear database engine for MySQL already, and we realized that this was not going to end well. We needed a distributed system. So for us to bring in Hadoop, that was just something, oh, hey, this is going to save us. Let's run it. So.
Different customers and users have different experiences too. It depends a little bit on the use case. Many customers start off with a simple ETL and cleansing use case, and then advance into more advanced analytics and machine learning, like Mahout, the machine learning library. It depends on where you want to start, but there's also a lot of training and material online these days. So. It shouldn't be too hard. And if you need help, call Cloudera. Yeah.
I mean, if
Happy
you
to help.
add Hive on top of it, I think it's sort of an excellent way to start working with it.
Yeah.
You don't have to write custom reducers the first thing you do. Just
Yeah.
play with the data in a SQL-like language.
All right. Great use case. It's been fantastic to have all the good questions and your attention for this time, and I hope you continue to enjoy this year's JFocus. Thank you.